Alright, so let's test now how much you guys all remember from your trigonometric properties. So in this module, we're going to be working with the trigonometric properties that we've all learnt before, I'm sure, which you all remember, except this time we'll be using inverse functions. So we'll see how we use these properties when it comes to inverse functions. Now, why we've listed these ones on the board is because they're going to be used in each of the questions. So they're just an example of your trigonometric properties, okay? It'll be good to go back and revise them all, but just for the next 5 questions, I want you to remember your double angle for sine, and then also your expansions for tangent, and then also your sine expansion, as well as remember that sine alpha equals to cosine 90 minus alpha, okay? So each one of these is used in the next questions. All right, let's start off with question 6 here. So we want to find the exact value of sine to inverse cosine of 4 and 5. Okay, so if the 2 wasn't there and you just saw sine and inverse cosine, what would you want to do? Yeah, that's right. You'd only want to make the input equal to x, right? And that's exactly what we're doing. We're just making the input and we're ignoring any of these values in front. So if it's 2 or 6 or any numbers, we're ignoring that. We just want to make inverse cosine 4 and 5 equal to theta. All right? And now, since we've let this equal to theta, that means that this is theta. So we can say that this now equals to sine 2 theta. And this is when we need those trigonometric properties, which I'm sure you know that this equals to 2 sine theta cos theta. Yeah? Okay, so if we know that this whole thing equals to 2 sine theta cos theta, it means, well, we need to work out what sine theta and what cos theta equals to. So working from here, we can switch the input of inverse cosine with the output, which means, and also switching the sign, that cos theta equals to 4 on 5. Yeah? And now we just want to draw our Pythagoras triangle. And we know that cosine theta is going to be adjacent on hypotenuse, right? And now to find out the other side, using Pythagoras, this is going to equal to 3. So we've worked out that sine theta is going to equal to what? Yep, excellent. It's going to be 3, your opposite on your hypotenuse. Now we've worked that out, it's just a simple matter of substitution. So this is exactly the same as that because we've made this equal to that, yeah? So therefore, this whole thing is going to equal to 2 times sine theta, which was 3 on 5, times cosine theta, which we worked out to be 4 on 5, and you just need to put that into your calculator and you should get 24 on 25 as your answer. All right, so can you see here that with this, don't forget about the numeral in front, whether it's 2 or 100. We just want to put the input without the numeral. So inverse cosine 4 and 5 and let that equal to x or theta. And therefore we've made it into sine 2 theta, expanded it and just worked it out from there. And since this was exactly the same as that, we could conclude the exact value was 24 on 25. So with all your inverse functions, remember that your trigonometric properties can apply anywhere. So always be on the lookout for them. And the best way to be on the lookout for them is if you just know them off by heart. So I really suggest that you need to memorize this, put it on your fridge, put it somewhere you'll see every day and just know them completely. Okay, let's look at question 7 now. So here we want to find the exact value of tangent of inverse sine 5 on 13 minus inverse cosine of 3 on 5. So this is the first time where we have all three. We have tangent, sine, and cosine, don't we? But don't be concerned about it. Same process. So let's make the input equal to x and y, or in this case, we're going to say alpha and beta. So this equals to alpha, and let's make this equal to beta. And now we want to switch the input and output for both of them and change the inverse sine to sine, inverse cosine to cosine there. Okay? Now looking back to the question, we want to find the tangent of this minus that. But because we've let them equal to alpha and beta, we now want to find tangent of alpha minus beta, don't we? Yeah? Alpha minus beta. And this is your trigonometric property where we can expand that to become tan alpha minus tan beta over 1 plus tan alpha tan beta. Yeah? Okay, that means we need to find out what tan alpha and tan beta equals to. And the best way to do that is always with our triangles. So let's work out the alpha triangle first. So with the alpha triangle, we have that sine alpha equals to 5 on 13. So that's going to be your opposite on your hypotenuse. Yeah? So this is your alpha. And then we can also work it out for beta. So for beta, we know that cos beta is 3 on 5. So that's going to be your adjacent on your hypotenuse. Now, let's work this one out. So we want to have 13 squared minus 5 squared and square root of that. So that's going to give you 12 for that, isn't it? Whereas this, we have 5 squared minus 3 squared, and that's going to leave you with the square root of that, give you 4 there. So now we've worked out that tan alpha equals to 5 on 12. So let's write that up here. Tan alpha equals to opposite on adjacent, so 5 on 12. And tan beta is going to equal to what? Good, it's going to equal to 4 on 3. And now all we need to do is just substitute that into the formula. Yeah, so simple case of substitution, but I always recommend that you write this in your paper. Just in case you make a mistake on your calculator, you don't want to lose all your marks because you didn't have time to write this. Yeah, write that out. And now we can put that into your calculator and you should get negative 33 on 56. And with our final answer, we want to rewrite this whole value here because that's what we're trying to find out, and say, therefore, the exact value of this is negative 33 on 56. So similar to the previous questions, here we've only found out that tan alpha minus beta equals to that, but that's not the point of the question. The point of the question was to find the exact value of that. So we have to show the examiner that we understand that. So that's why we need to write that final statement there. All right, so you can see here when you have all three, tangent, sine and cosine, don't need to be worried. We're still just making the input equal to x and y or alpha and beta. And then here we've used the trigonometric properties and we've just substituted in the values. Okay, so it's quite similar, just probably a little bit more work. All right, let's have a look at question 8 now. So here we want to find the exact value for inverse tangent of 1 on 2 and then also inverse tangent of a third. So first thing we do, let them equal to x and y. Now switch the input and output and make that into tan. So we have tan x equals to half and tan y equals to a third. Now we have to somehow work out what x plus y equals to, don't we? So here we've made this into, let that be x plus y. So just keep that in your mind. At the end, I want to work out what x plus y equals. Now, how am I going to bring them together? Well, how you can do that is by using the tangent of x plus y, okay? So keep that in mind. We're not finding that out. We're just using this to find out x plus y. So remember, tan x plus y equals to tan x plus tan y, 1 minus tan x tan y. Okay, and now since we know that tan x equals to half and tan y equals to a third, just substitute that in, write that out, okay? Put into your calculator, and you find that that equals to 1, which means that the tangent of x plus y equals to 1. Now, a lot of students are gonna get confused and write this as your answer, but if you've written that at the top of your page, you know, wait a minute, I need to work out what x plus y equals to. So we can switch the input and the output again to find out that x plus y equals to inverse tangent of 1. Yeah? And remembering your exact values tables, that equals to 45 degrees. And we always write that in radians, so equals to pi on 4. So therefore, we've worked out that x plus y equals to pi on 4, but because the question asks for this, we have to once again write it out as inverse tangent of half plus inverse tangent of a third equals to pi on 4. Alright, so this is a very specific question. So don't worry if you think, oh, how am I supposed to know when I'm going to have to use tangent of x plus y? Just know that if a similar question comes up, you can follow the exact same process. But the important thing that a lot of students get confused about is they're going to stop here because it looks like that you've gotten the answer for that. But if you remember, you're actually finding out what x plus y equals to, and write that on the top of your page. It will remind you to keep going to find out the actual exact value for that. All right, so let's move on to something slightly different. Here we want to find the exact value of inverse sine x plus inverse cosine x. So similar to other question, what we have here, it's two different ones, but what we need to do is just let it equal to A, let it equal to B, same process, all right? So starting off with your inverse sine, let that equal to A. And now we want to switch our input and output. So our x and the A switch, so therefore the sine switches as well. So that's how we get that x equals to sine A, yeah? That's how we've gone from this step to that step. Now here is the important step. We need to think back to our trigonometric properties and remember that sine A equals to cosine of 90 degrees minus A. Yeah, do you remember that property? So we've made that equal to this. So now we have that x equals to cosine of pi on 2 minus A. Yeah? Okay, so somehow we're working inverse sine with cosine, but we want to make the cosine into inverse cosine now, right? Because up here it's inverse cosine. So how am I going to do that? Well, I can switch the input and the output, and that's going to switch my sine as well, isn't it? So therefore, you will have inverse cosine of x equals to pi on 2 minus A. Now, remember how we let A equal to inverse sine x? So I've just substituted that back into here. So now I have inverse cosine x equals to pi on 2 minus inverse sine x. Yeah? And if I move that to that side, I found that inverse sine x plus inverse cosine x equals to pi on 2. Okay, so this is quite a specific question again, but what I want you to appreciate is if you do get lost, just choose something, let it equal to A or X, and we can always work from there. So can you see how here we've switched the input and output, then we use a trigonometric property to link sine and cosine? And because we want inverse cosine here, that's what told us that we needed to switch the input and output to make that inverse cosine, okay? So we're always looking up at the original question to ask ourselves, what do I need to do? It's easy to actually get lost from the original question because the algebra does become quite complicated as we go on. So just keep looking back to see what you need to do. Okay, so that was question 9. Let's have a look together now at question 10. So in question 10, find the exact value for sine of inverse sine 3 on 5 minus inverse cosine of 4 on 5. It's being very nice. It's letting us know that we want to let this equal to x and to let that equal to y. So letting that equal to x and y, the next step we want to do is to flip our input and output. So, and change the sign. So we get sine x is 3 on 5 and then cosine y is 4 on 5. Now here we want to find the sine of, we let this equal to x, didn't we? And we let that equal to y. And what does this remind you of? Good, it's your trigonometric property where we expand that. And that expands to sine x cos y minus sine y cos x. Okay? And now we just need to substitute in our exact values for each of them. Well, we already know what sine x equals to here, 3 on 5. And we also know that cos y equals to 4 on 5. But we need to find out sine y and cos x, don't we? So let's start off with our x triangle. So here, I know that sine x is my opposite on hypotenuse. Okay? So my adjacent is going to be 4. I think by now we know that without even going through the Pythagoras formula, don't we? Which means that we've worked out that cos x is going to equal to 4 on 5. Yeah, adjacent on hypotenuse. Let's draw the triangle for our y. So we know that cos y is 4, your adjacent, on 5. So that's going to be 3. So sine y is going to equal to what? That's right, it's going to be 3 on 5. So therefore, substituting into this equation, you should get 3 on 4 times 4 on 5. And we worked out that cos y was going to be, cos x was 4 on 5. That's what we have there, times 3 on 5 for sine y. Put that into your calculator and it actually all ends up equal to 0. So therefore, your exact value for this equals to 0. So you can see here, because we've written that out as our first thing, it's showing the examiner, no, this is what I'm working out. Whereas in our previous questions, we actually took, a route from that and we were working with something else. So it's okay here because you can see we're working from that. It's continuing from that. All right. So with this question, I think it kind of combines all your previous knowledge of these trigonometric properties and also with inverse formulas. So what you need to keep in mind is to always keep a lookout for your trigonometric properties. I will promise you they are going to come up with your inverse functions. And you always need to remember to draw your triangles. That is the best way to work out your exact values, because otherwise it's easy to get confused. Doesn't take very long to draw the triangles, as you can see. So remember those things and we should be right with all these questions.